Okay, well, we're right at noon. Welcome to everyone's chiming in now for our live lunch and learn that we do every Wednesdays at noon Pacific Standard Time here at Kuker-Ranken. We're also streaming this live over to Facebook, so we want to welcome any Facebook viewers that we have out there as well. My name is Douglas Spotted Eagle, and I am the Chief Strategy Officer here at Kuker-Ranken. And joining me today, we're very excited to be bringing in Brian from Leica or Hexagon. Brian, do we say you're from Leica or Hexagon?
I say Leica Geosystems.
All right.
Hexagon is just too confusing.
So we're very, very happy to have Brian from Leica Geosystems with us today, as we're going to go through the new Leica BLK2FLY drone. It's Leica has been involved in the drone world for quite some time, and I think you've been heading that up for the majority of its lifetime. Is that right, Brian?
Yeah, I came on specifically to head up Leica's drone program back in 2014 when we made our first acquisition back then to a photogrammetry platform. The BLK2FLY is, however, a completely internally built system and a completely different application than our previous platform. So I'm excited to be here with you today, Douglas. Thank you for inviting me, and look forward to sharing some really cool tech with your customers.
I'm looking forward to sharing your stories with our customers as well. I think that's the real value in having you here. You're a highly experienced pilot. You have quite a background in mapping and survey equipment and precision equipment. Why don't you tell folks a little bit about some of your background, aside from the fact that you did join Leica Geosystems for their UA program?
I've been in the geospatial industry for my entire career. I started developing data collector software back when total stations were brand new, because my background is in computer science. However, that morphed into sales, territory management, and then dealing with a lot of other products, including GPS, high definition laser scanning, construction instruments, all of that. And then secondarily, aviation's always been a passion of mine. And so when drones came on the scene in 2012, there weren't any regulations then in the US at that time. And then that morphed into needing to be an actual aircraft pilot to fly drones. And then that's where I kind of stepped over the line and into drones pretty much permanently full time. I am a certified UAS photogrammetrist with ASPRS. And I'm also a certified flight instructor. So I teach flight lessons on evenings, weekends, and early mornings in Phoenix before about 7 a.m. because it's too damn hot in a 172. So that's a little bit about me. Thank you.
Hey, that's high class. If you're training in a 172, I started out in a 152, 152, nice. And then went to an Aeronica.
Oh, nice.
That was a
love the Champ.
Yeah,
the Champs are a blast. Those are just fun. Yeah,
they are. Well, folks, in front of you can see the BLK2FLY. This is a great illustration of what it looks like. We'll just get right into it. One of the things that we want you to know about the BLK2FLY it is a fully autonomous system. So this is not a tool that you need to have tremendous piloting skills. Of course, you do have to be certificated by the FAA with an FAA 107 certificate or a UAV pilot certificate in order to fly this, because it is a commercial operation. However, it's an autonomous flying drone, and it does not require manual flight at all. In fact, Brian, are there any points of time where manual flight might be an option or an ideal for people with this aircraft?
Yeah, there are. There's some times that you may want to get into a place that's a little bit difficult to actually plan for, or you may want to get some more detail into a specific area. However, in addition to traditional joystick type of inputs through the virtual joysticks, we have gesture controls. So if you can operate a tablet or an iPhone, you can basically fly the BLK2FLY. We use gestures such as swiping on the screen to rotate the aircraft left and right. We use pinch to zoom in for flying forward and pinch to zoom out to fly backwards. We use double tap on the screen to fly to in a particular direction. All of that while the aircraft is using its LiDAR and radar to avoid any obstacles. So it'll use this the data that it collects to actually map its environment and learn about its environment. So if you tell it to go in a particular direction and there's an obstacle there, it's going to try to figure out whether it's better to go around that obstacle or up and over that obstacle. And that applies to the flights that it does as well. So again, we've made it easy for even novice pilots, but there are certainly times where you may want to do some manual maneuvering to get into an optimal position for what you want to tell the aircraft to collect.
I think you did some of that in one of the data sets we've got coming up here in just a moment.
Yeah, I do it. I do it a lot. Yeah.
But tell folks about the hotspot battery system. For me, that's one of the most exciting factors of features of the aircraft.
Well, a lot of time can be wasted by shutting an aircraft down and firing it back up. The systems, the sensors have to reinitialize, has to reacquire GPS connectivity, connectivity with the controller and things like that. But with our hot swappable battery system, if the aircraft's not finished performing the mission that you told it to perform, it's going to come back and land either where it took off from or at the controller where you're standing, your choice. And then after it lands and the motor shut down, the aircraft is still on and is still communicating with the tablet, with GPS, all of those things. And you simply slide one battery off, slide the other one on within 10 seconds. The aircraft never completely shuts down, is ready to take off again. And then you just hit the continue button and it goes and flies back right to where it left off and picks up where it left off to continue scanning. So that alone can save you a fair bit of time in the field if you think about how long it takes to do an initial startup, which granted it's only a couple of minutes, but a couple of minutes here, a couple of minutes there, pretty soon you're talking about, you know, some significant time.
Yeah, absolutely. One of the things that we'll wrap this particular slide up with pointing out that this system is of course easily combined with other scan data, and we're going to show some of that as we come through. So the data is the data that this system collects and outputs is compatible with many of the software systems. We've been working with it in Cyclone 3DR. Pretty excited to work with it. So one of the things that we want to share with folks about this particular aircraft is this is not an aircraft that you would buy for surveying large pieces of property. This is really something that you would be using in an area where you've got vertical structures, or such as inspectable areas, or if you're working in construction and you need to get these vertical structures. This is not an aircraft that you would fly over for dirt work. So for example, if you were trying to calculate cut fill volume, this is not the correct aircraft. Where this is a very useful aircraft is when we have vertical structuring or inspection of different environments, and we can capture great detail either fairly close in or at a standoff. It's great for getting in very, very tight on various types of vertical structures. So Brian, why is it, or can you offer any input as to why Leica decided to take on an entirely different direction than pretty much anybody else has done to date?
Well, as you know, Douglas, the mapping space for drones is very saturated and very competitive. You can get a drone that will do topographic mapping applications, you know, for $1,000 all the way up to, you know, tens of thousands of dollars. So it's a very tight space. And the reason it's such a tight space is because there's not a lot of intelligence required to operate in that space. Basically, a drone just goes up to a certain altitude and flies back and forth over a particular area, snapping enough photos to cover that area sufficiently to create a stereo model. With the BLK2FLY, it's using a lot more intelligence. And this is something that most drone manufacturers just don't either have the capacity or the technology to implement into a flying platform. And so we are capitalizing on our strengths as Leica Geosystems to incorporate our technology, our SLAM, in this case, our Grand SLAM technology that comes out of our BLK2Go and our BLK360s and some of our other scanning products into a flying version of those terrestrial products. And that complements our tool set with the BLK product family. As I mentioned, the BLK2Go, the BLK360, those products that are terrestrial based or mobile based, BLK2FLY is the aerial component to that, getting into those places that are either too difficult or too dangerous to take that particular product. So it's not just about a particular product or flying drone, flying laser scanner. It's about complementing a complete tool set. In this case, we're specifically talking about the to-fly, but the to-fly is going to be in the same use cases as those other products, which you mentioned, construction, BIM application, architectural, historical assets. In fact, just today, I was on another call previous to this meeting where the customer told me what they wanted to do. They wanted to do a large volumetric type of topography survey of a mining area. Like, the BLK2FLY is not the right choice for that. So, I steered him to another photogrammetry platform. And but he did indicate that at some point he anticipated needing a to-fly where a photogrammetry platform just really isn't going to fit the bill, as you'll see in some of the data that we get to in a little bit.
Well, before we move that data, you mentioned the SLAM technology. For those that aren't familiar with SLAM, I had it on a slide earlier, but I didn't have a definition. So those of you that aren't familiar with SLAM, it's simultaneous localization and mapping. And Brian, you used a term there that I'd not heard before, and I kind of like it. Grand SLAM. What is Grand SLAM technology compared to SLAM?
Grand SLAM is the addition of RTK GNSS. In addition, yeah. So, and that's why we call it Grand, as far as the G and GPS, and it also is kind of catchy and as a baseball term, Grand SLAM. Right. So what that allows our system and our software to do is not only to scan a particular area and scan it very well and very, very accurately as part of the SLAM, and also to navigate the aircraft, but also as we bring in multiple scans, the GNSS positioning of those scans comes in automatically pre-registered to one another. So the amount of work that we have to do to register the scans together is minimal at best. In some cases, we don't have to do anything. The aircraft with the RTK GNSS is positioning itself and positioning the scans within plus or minus about 2 centimeters as it's flying. So the GNSS, and we're using RTK GNSS, so the aircraft's actually getting RTK corrections from a network correction source, such as our SmartNet, but there's other networks out there, some that are being run by states like TxDOT and Caltrans and MnDOT, and some other states that run their local statewide GNSS networks that we can tie into those as well. But that's the G for the Grand in Grand SLAM.
I like that, and I had not heard that term until you used it. That's a new one for me. Well, you mentioned some specs here. So, folks, we give you an idea of total size. You've got a 53 centimeter by 60 centimeter by 19 centimeter airframe. So it's not huge. It folds up really easily. You can put it into a small case that fits into an overhead. It's IP54 rated, so if you're working in environments where there might be a lot of moisture in the air, bear in mind it is LiDAR, so LiDAR is not going to be terribly effective in wet environments, just for the simple fact that we get reflections with LiDAR off of different things. But it's got a 360-degree optical avoidance, so it protects itself in an environment. And as Brian mentioned, it is using the data that it's collecting as data to also prevent it from striking a surface. It can be connected over Bluetooth LE or low energy or over LTE, and it's got 256 gigs of internal storage, which might not sound a lot like a lot of storage to those of you that are familiar with the photogrammetry world, but this is LiDAR data. This is basically just binary data. And so this binary data is quite small in the amount of storage that it requires, and it's also very, very fast to write. So that's one of the reasons why we don't have to see a large drive here, is because there's no pixels involved. This is just laser scan data or binary data, as we would refer to it. And it's scanning at 420,000 points per second. So it's got quite a scan ratio on there. Brian, you want to talk just a little bit about the scanning for a second? And I've got a slide later on that shows the angle. You could speak about that now as well, if you'd like.
Right. Well, I've got the BLK2FLY here. My background image is blurred, so it doesn't show up as well. But the aircraft just basically opens up like this, and it's ready to go. It's 5.7 pounds, so it's very lightweight, very portable, easy to maneuver and get around. The as far as the laser scanner goes, and this is something that's really pretty unique when it comes to LiDAR drones, is that the laser scanning in a 360 degree, so this is the nose of the aircraft, the laser scanning is scanning in a 360 degree area around the axis of the aircraft, but then it's also scanning in a 270 degree front to back. So 45 degrees up and behind to 45 degrees down and below. So as the aircraft actually passes over some sort of object that has some vertical structure to it, like a parapet wall or a fence or something like that, it's actually getting the data on the other side of it simultaneously. It's actually, scanning backwards as it's flying forwards. So this means that you only have to get one pass of a structure to get the entire structure. Most other LiDARs, the LiDAR is only pointing in one direction, and not only do you have to possibly make multiple passes with it, but you also have to make multiple passes with the LiDAR at multiple angles. So this is considerably time consuming, whereas with the TFLY, you only have to make the one pass with it.
Brian, we just had our first question come in from one of our customers, and I don't have an answer to this. Does continuous battery hot swapping lead to burning out the drone? Have you tested it enough to have an answer for that?
I've run 10 consecutive flights on it. That's the most I've run because that's all the batteries I had, and I didn't have any problem with burning out the drone. It's not really a function of the batteries heating up the drone. So again, no problem with that. But we will have some environmental conditions where it can be too hot for the drone because of the LiDAR, and we just have to manage that in terms of the particular environment that we're in. I live in Phoenix, so I try to get my flying done as much as I can in the morning, because on a 113 degree day, you're going to heat up the drone beyond its specs after a couple of flights. So again, just something we have to manage, just like we have to manage, flying in the cold if we're in Canada or something.
Thank you for that. The folks in front of you can see the controller. You're seeing three different views coming from that controller. We see a live view, which is basically an RGB camera view. We're seeing the 3D scan view. We're seeing live LiDAR data as it's coming into the controller. Now we've got our aerial image or our image from up above. Brian, you provided these particular shots to me. Is there anything you want to share with our audience about these?
Well, not specifically about these images, but about the controller itself. We use an iPad Pro as the controller, and the iPad Pro is Wi-Fi and cellular enabled, and the iPad Pro communicates with the BLK2FLY via cellular and Wi-Fi at short distance, cellular at longer distances. But the ease of use by using an iPad makes the aircraft really simple. I mentioned that a few slides back where we have the gesture controls. We also have virtual joysticks, so it's not a hard joystick, but it's virtual joysticks on the tablet. Basically, you just slide your thumbs around, and wherever your thumbs land on the screen is where the center of the joystick is. And you just have to slide your thumb. So that makes it very easy to operate, and you have the three different views for different purposes. Of course, situational awareness and pilot visualization is the primary goal, but also through the live view from the cameras, because there's 5 cameras on the aircraft, forward facing, of course, right, left, up, and down facing cameras. And so you see what it is you want to, or what's in your field of view, and then you just tap a polygon around the area that you want to collect and hit go, and the aircraft goes and gets it. And then you can flip between the screens to see your live view from the cameras and then what the LiDAR is collecting. So you can see where you may have gaps or areas that you want to get a more dense scan on. And then finally, the plan view just shows us where we are in relation to our site using a Google Earth image. So that's the 3 different views that you've got, and how they're typically used. I'm usually switching primarily between the live view and the in the 3D view. One other thing that I've neglected to mention in terms of flying the aircraft, in the 3D view, you can actually just click one of those LiDAR points that's in your 3D view and hit go, and the aircraft will just fly to it. Doesn't matter if it's on the other side of a building, doesn't matter where it is, the aircraft will just fly to that particular location.
I think here we've got some live views that are happening in front of people here, some video you captured of the job site.
Well, these videos are of the data, so it's not actually there is yeah, so what you're seeing is both imagery and point clouds. This is actually data. So this isn't coming from the tablet controller. This is coming from Register 360 after the data has been imported and processed. So you get both imagery as well as point clouds, just like you do on a BLK 360 or BLK2Go or RTC 360. So yeah, these are just some data samples.
So here we've got a surface that you scanned. Looks like you went out and scanned. So if I understand this right, Brian, all we need to do is take off or launch the drone, grab our virtual joysticks or put our thumbs down and it automatically centers that joystick. We click on the plus or minus button to create a surface and hit play, and it goes and captures the surface. Is that all there really is to it?
Yeah, Douglas, if you hit the video play button on this video screen that you see here, up in the upper left-hand corner, we actually have the tablet view. There you go. And pressing the takeoff button in this lower right, the aircraft will start up and take off. And what you're seeing now is the, whoa.
It didn't get me into the video there for some reason.
Oh, you were running. It was running.
Oh, was it? Okay. Oh,
yep.
I didn't realize that was the whole thing was the slide. I'm sorry.
That's okay.
Yeah. Well, I must have taken it too far past. I'm not able to get to restart the video. I'll go to one ahead of it again and see if I can get that to go.
Okay.
There we go. I did not.
All right, so there you go. So just
there we go. Got it. Yep.
So just let it run for a second now. So the aircraft takes off, and again, we're looking through the front camera in the live view. And once the takeoff is done, they're going to go to the full screen. So now you're seeing the full screen. We press the plus button to tell it we want to create a scan, and we tell it that we want to create a surface scan. And then we just tap the corners. We can pan in the cameras. We just tap the corners in the area that we see. And then we hit the checkbox down here at the bottom, and then we press the play button. And then we switch over to the 3D view, and you can see the data that's already being collected from the LiDAR. And then the aircraft goes and begins collecting the scan. So the interesting thing about this is that the portico on this building is actually an obstacle in the flight plan. You can kind of see the flight plan cuts through the portico. But as the BLK2FLY flies this path, it'll detect the portico, it'll retreat from the surface to get around the portico, and then as it has passed around it, it'll go back in towards the facade. So obstacle avoidance is all completely taken care of by the aircraft itself. And again, on the next flight line, it would do exactly the same thing, go around the portico. So it's just a matter of using the screen to find what you want to capture, drawing a polygon around it, and then pressing the play button. So you can go ahead and proceed.
Outstanding. So one of the questions we have is, does this system also run on Android? I believe it only is on iPad.
No,
or on iOS.
Only iOS, iPad Pro. Yep.
That's what I thought. Okay, so next up, we've got some scans that this is your next video slide here. Or that just restarted?
It's still the same video, but
okay.
You can kind of see now that the aircraft is going to fly its flight plan. And as it makes this first pass, it's going to, again, detect that portico and then back away from the facade of and you can see that there's a tiny icon of the drone. So you see the drone in 3D as well and where it is. And once it gets past the portico, it moves back in. So you remember a little bit earlier, I mentioned that the LiDAR is scanning in 360 degrees this way and 270 degrees this way. However, the drone also has radar detectors on its sides and rear of the aircraft. So we can detect obstacles down to 5 millimeters in size. So you can't back it into a pole. You can't side slam it into the side of a building or even a quarter-inch cable. So the drone will detect that, and if it's in its flight path, it's going to figure out whether it's better to go around it or over it.
Yeah, can it also go under an obstacle, or is it restricted to around or over?
Yeah, it's not going to go under. If it can't figure out if it can go over or around it, it'll stop, and you'll have to position the aircraft manually.
Okay, so Jonathan, we're gonna answer your question about the BLK scan as we go into a couple of slides here coming up in the future. There we go.
Yeah, you can see that roof structure is pretty complex. And with the spires and the chimneys and the steep pitch of the roof, there's another video that I actually have of it doing the roof, and it basically hugs the roof line and then goes around the chimneys and the spires automatically. All we have to do is just give it the plan of the area of our roof and set the altitude that we want to start at, and we start at basically the height of the bottom of the roof line, and then the aircraft will just go up and over it.
Brian, we're starting to run a little short
Yep.
on time. I've got some technical hiccup with that one slide. My apologies to our viewers, but here's this is a piece that we scanned during the Hexagon show in Las Vegas a couple of weeks ago, and this current slide that we're looking at right here, I think this is just the BLK2FLY that captured this. Is it, Brian? Or no, actually, that's two data sets I can see there. Yeah.
Yep.
What this was the BLK2FLY and the BLK2GO.
Right.
So RD, I see your question there. Does it work in the light? It's LiDAR, so light is not so much a function nearly as much as it would be if it was photography. So let me slide into a couple more of these Venetian pieces. Brian, you want to tell folks what we're looking at here?
Well, this is just, I wanted to get a quick combined data set to show how the BLK2FLY data integrates with the to-go data, or the BLK, or the any of our data sets, any of our scan data. In fact, we can even bring in an unstructured photogrammetry point cloud that was generated from a photogrammetry drone and tie that in with the BLK2FLY or BLK2GO data using Register 360. That's a new feature in Register 360. But I was really pleasantly surprised at how well the to-go and the to-fly data came in and aligned together extremely well. You're not going to get the crispness with the to-fly or the to-go data that you get with a P-series or even an RTC, and you're also not going to get the density of the point cloud because those products are scanning at much higher density levels. But you are able to get data that you couldn't get before in areas that are, again, as I said, too dangerous or difficult to get to, and tie it to your existing data. So the BLK2FLY can not only provide you with data for like a complete project, but it can also provide you with context to a project that maybe you needed higher definition for in a certain area, but not high definition for in the entire scope of the project. So here you're looking at the underside of this structure where we couldn't fly the BLK2FLY, but I just walked the BLK2GO down there through it and aligned, and that data came in and aligned very nicely with the to-fly data.
Brian, we have a question from one of our guests. Does it have a minimum obstacle distance, and can we override any minimum obstacle avoidance distance?
You can turn off the obstacle avoidance at your own peril. So you want to make sure that you're fairly experienced and know what you're doing when you do that. The one question that I see is work in low light. That's tough. we can't work in the dark. The VIS system, the visual flight controller, requires light. I can't really say exactly where that level is, but typically in an indoor environment, we're going to run into lighting issues in addition to the GNSS issues indoors. So right now, this is only an outdoor daylight product. So just to kind of set that expectation level, we are working on improvements in the autonomy and the automation for indoor and lower light applications.
Yeah. So bear in mind that's predominantly for, or correct me if I'm wrong, Brian, but that's predominantly for obstacle avoidance, etc. Unless can we get a non-colorized point cloud out of the BLK to fly?
No.
Okay. So it requires light no matter what, even for its imaging.
Yeah.
Good to know. That was something I was unaware of. Well, folks, that brings us to the end of our opportunity to chat with Brian and learn more about the BLK2FLY. But if you want to contact Brady Reich or Brian Worthen, are our two BLK2FLY subject matter experts at Kuker-Ranken, and they can be found in our Salt Lake City store and in our Las Vegas store. But we also have scanning gurus in all of our different stores across Kuker-Ranken. We also want to share with you that we're about to leave off on our Roadshow 2022. We met many of you at our roadshows last year. We're looking forward to seeing you at roadshows this year. You can see a quick schedule of when we'll be in your area, and we will have a BLK2FLY on the tour with us here. You'll see a variety of other unmanned aircraft for different kinds of purposes. I do want to stress that this is a very unique and high benefit tool. It's a little different than other aircraft, but because it's a little different, it can provide a very different type of data set and get into places that other aircraft are just simply unable to go. So it fills a really nice niche out there. So with that, I'll finish up by thanking you for being here with us today. And we're looking forward to seeing you at our next Lunch and Learn we have next week. We're going to be showing some data with some of the other Leica equipment. I believe the AP20 is the next one. It's either the AP20 or the GS18I. I don't have that up in front of me.
I think it's the AP20.
Is it the AP20 that we've got coming up? Thank you for that.
Mm-hmm.
We've got the AP20 coming up at our next Lunch and Learn. We're real thrilled to have you folks here for that. Brian, thank you very, very much for coming in and being a part of this particular Lunch and Learn. And we look forward to having you at future Lunch and Learns.
Yeah, anytime, Douglas. Thanks for the offer and the invite. And just so some people know, I'm to be determined. I'll be at some of your UAS events. So
we're grateful that you'll be on the roadshow with us as well.
All right. Thank you.
So, folks, on behalf of all of us at Kuker-Ranken, thank you so much for being with us this afternoon. We look forward to seeing you at our next. Take care.
Bye-bye.